power. True. All right, here we go, guys. So remember that last time we were here, we were looking at exponential functions, the graph of exponential functions. So remember we had that parent graph, the one that's everything else is based on, and then we looked at how adding something to the exponent and adding something to the base of the exponent or subtracting it would move that function around, right? So first of all, let's just talk about that. So remember those parent graphs of the thing. So if you have f of x equals p to the x, right? Just the basic function, p to the x. Remember, it always goes through 0, 1, right? Because 0 power is always 1. And as it does not exist here, instead you get a little dotted line called an, do you remember? Asymptote. Yeah, remember that? And then it just goes down and it approaches that line and infinitely closer, but it never touches it. And then over here, it just goes up infinitely, right? Then, okay, so f of x equals p to the x. It's not a parabola. This is what we did last time.
We did?
2 days of it.
What are these called?
Exponential functions. Okay? Now, then, if you start adding or subtracting, start putting in your B and C, they do exactly the same thing as any other time you did it. Right? B shifts the graph what? Which direction? Side to side in the opposite direction, right? So if it's plus 2, that really means you're going to go 2 to the left. Good. C shifts the graph what? Up and down. Right? Remember those? No. Okay, well, you're going to see some anyway. So today what we're going to do is we're going to look at how we can come up with the equation if we have the graph. Okay? Now there are a couple of things you need to remember. You need to remember that this basic graph of any exponential with nothing added to any part of it always goes through the same exact point. What is that y-intercept always? 0 what? 1. Because f of x, if it's like 2 to the 0 power, what is 2 to the 0 power? 1. So if x is 0, y is always 1. No matter what. Pardon me?
So x is always there.
No. For the basic graph. If it's just a plain old x, if you just have x to the 0. Okay? So you're just finding this y-intercept. It's just an important part for exponents. You don't usually use it for any other thing. Right? And it doesn't matter what power you have. If your function is 3 to some power, 3 to the x, if x is 0, that turns that whole thing into a 1. So no matter what exponent you have, if you raise it to the 0 power, you're going to get 1. So anytime x is 0, y is going to be 1 in that basic graph. Right? And then we just have to look for what our b and our c are doing to find the rest. It's very straightforward. Okay? All right, here we go. So we're going to go to the... Well, if it's just plain old, if it's just plain old something to a power, okay? So it's just a really important part, and only for exponentials. Remember, it's only exponentials that do that. Okay, so what we're going to do is we're going to go to the book, and we're going to look at the steps, the process. The book does a really good job of describing these. So let's go to the book. Here we go. Shh, ladies. Writing equations for exponential graphs. I guarantee you'll have to do this on the test, so come on. All right. Now, first of all, the basic general form equals P, and it can be plus or minus, right? Because it can be negative or positive. What's a negative one going to do? Instead of going up, it's going to go down. Same exact process. Okay. For y equals plus or minus, so you have an x plus or minus some b and plus or minus some c. That's the general form of an exponential function, right? Now, you don't have to have something added or subtracted from your x. You don't have to have added, you don't have to have a c, right? Your p can be either positive or negative. Just changes the direction of the graph, up or down, right? Just like a parabola. Okay, so what we're going to do is we're going to use this information, this general form, to be able to find all the pieces we need for the equation. All right, so let's look at it. So the first thing we need to do, the first step, and I'm not going to rewrite the steps, you need to, but I'm not going to rewrite the steps because this is one time the book and I really agree on the steps, and I'm not going to change anything. First step, I will clarify a few things, though, because they just assume you know stuff. I hate that. First thing, draw the asymptote, okay? Now remember, the asymptote of an exponential is easy to find because it's just the line where the bottom of the graph, where it starts to look like it's going flat. So whatever number that is. So in this case, it's right here, and that's at -2. Right? Okay.
How do you spell that word?
Asymptote. Asymptote. No worries. Okay. All right. So once you've found the asymptote, right? You're going to look, okay, now be careful here. Remember that 0, 1 point is really important. That's where if the graph didn't have any B's or C's, it would go through 0, 1. So we can use that fact to find the shift. In other words, find out your C and your B. Okay? So if this graph was just a plain exponential, it would go through that point. Do you agree? Now remember that point is, and remember where would the asymptote be if we had that point? It would be at 0. Remember that parent graph? Is that coming back to you at all? Okay, it's not a big deal if you don't remember it. So if you look at that, how many units above the asymptote is that point? 1 unit. So that means that our critical point for us then is 1 unit above the asymptote. Always. No matter what.
Always
1 unit above the asymptote. No matter what. Okay? So if you look at this one, here is where the graph is 1 unit above the asymptote. Do you see it? So for exponentials, you're always looking for the place where it's 1 unit more than the asymptote. Oh, I'm sorry. When you find the asymptote, whatever number that is, that's your C. So we already have part of it. So remember, we are doing y equals p to the x plus or minus b plus or minus c. So in this one, the asymptote is at -2. That's your C. Always. Okay? So we have that part. We have y equals. Now, we're going to mark the point 0, 1. You're going to draw arrows from that to the point where the curve is 1 unit above the asymptote. So you've got to go down how many units in this case? Down 2 units, right? So it's 2 units down. But we already knew that. Why? Our asymptote is 2 units down from 0. So that's down, shift down 2 units, that's our C. Our asymptote tells us that anyway. But to get to there, we have to go how many units? 3 to the left. Now remember, shift left and right is not a C, it's a B value, right? So that means our B is not going to be -3, it's going to be what? +3. So it's p to the x plus 3. So what we've done is, p to the x plus 3 up here. So what we've done is we found our A and B by simply looking at the graph and remembering that every single one of them, every time your critical point is that point 1 unit above the, what's it called? Asymptote. Okay? So very straightforward. Because it's 1 unit above, it's just simply like a magic point on exponentials. It's just like the vertex of a parabola. If you know the vertex, you can find out just about everything else. The asymptote has to be marked. Okay? All right, unless they give you the equation where you're drawing it. Okay. Yes. Okay, here we go. So Now, but notice, okay, so I have my B and I have my C just by reading from the graph. But I don't know what this P number is. P is the base of the exponent. Now, I'm going to tell you that the only way to make this work is if they use a 2 or 3. They will never use a number of P bigger than 2 or 3 because it makes the math crazy impossible. So, try 2 and see if it'll work. Now, the way to test it, look how they're testing it. Okay? So, let P equal 2. Well, remember, okay, and then we're going to find some easy point to test into it. So, if we let P equal 2, that gives us y equals 2 to the x plus 3 minus 2. But we need to test it to see if that is indeed the point. Yes?
So, does this go for all?
All exponentials.
Is all pretty much going to be 2 or 3?
All pretty much going to be 2. If they do 3, they're being really mean. Because it's really, the numbers get really big, really fast, or really hard. Okay? Can't be a 1 because 1 to any power is not going to help you. It's going to be 1. Okay? So it's generally going to be 2. They may give you a 3 one in here in your homework, but I doubt it. We're going to do plenty of these, so don't panic. So what we're going to do is pick an easy point on the curve to test. And the easiest point always is the Y-intercept. Because what's the x value at the Y-intercept? 0, right? So that's why they chose the Y-intercept. And that's just simply a test value. Okay? So we're going to choose 0, 6 as our test value. But you could choose any easy point. So let's see. Where else does it look like it's going through? Does it look like it's going through there? That's -1, +2. Any point that you can easily read the value of. But if it happens to be the Y-intercept, then you're that much ahead. So now what we're going to do is simply substitute to test. Okay? So in place of the x, I'm going to put what number? 0. In place of the y, I'm going to put what number? 6. Although, of course, I don't have a y. I have a y there. Okay, here we go. So when I solve that, so 6 equals y. I'm sorry, not y. Losing it. 2. Why am I 2 turned into a y? 2 to the 0 plus 3 minus 2. You see what I did? All I did was put 6 in place of y and 0 in place of x. Just substituting to check. Now let's do the math. So that gives us 6 equals 0 plus 3 is just 3, right? And what's 2 to the third? 8. Minus 2 gives us 6 equals what? Does it check? Yeah, 6 equals 6. So that means I know that 2 is the right base. If not, then I'd have to try 3. Now we're going to do several of these. If this is new and it's odd, I can't really think of any place that has anything like this. So I know it's new. And besides that, I know it's been, 4 weeks since we did asymptotes. Okay? So, and that's it. If it checks, then you know the base is 2, then you're done. If it doesn't check, then you need to try 3. But never think of it as being any number above 3. It's just too crazy.
I have a question from before. So, you know how you had a point and it moved down 2 units and
Over.
units? Why did you choose that point? Why was that point?
Because you always choose the point that's 1 unit above the asymptote.
But the point that it came down, like it went down.
You didn't have to. You're not worried about the down because you already have the down from the asymptote. So you don't even worry. Just right or left from the x-axis. Yeah, you're right. Overkill, math overkill. You know how they have to be so perfect. All right, so let's just look at a couple, and so you can see what I mean. I'm not going to look at their examples. Let's just go. You want to do one where it's scaffolded, or just go to one? Let's just go to one. All right, here we go. Okay, we have an exponential function. How do I know or recognize that that's an exponential function? Because it looks like one, right? It looks like kind of like half a parabola, doesn't it?
Looks like slide.
Yeah, there you go. Okay? So what I'm supposed to do is I need to find the equation of this. Now, what is the general form for any exponential function? Y equals what? P to the x plus or minus b plus or minus c. Okay? Now, we know that we have an asymptote here. And I lied to you. They didn't draw it. But where does it look like this is going flat? It's getting close to a line but not touching it. Where? -1. Well, that's automatically your C. Don't even have to think about it. Wherever that asymptote is, that's your C. Okay? It's been shifted down 1. All right. Because normally the asymptote on the parent graph would be at 0. But now it's at -1. So that means this graph was shifted down 1. Okay. Then, now we need to find out our B. To do that, okay, so first, find the asymptote. And that's your C. Okay? Okay, whatever that note value is. Then, find the point where the line is 1 above the asymptote. Okay, 1 unit above. So, where is this thing 1 unit above? Looks like right there to me, yeah? 1 unit above the asymptote? Okay. And what value is that? -2. So that means, okay, you'll just change that sign to get B. Right? So y equals P to the x plus 2. Make sense? So it's shift and translations, just like we've been doing before. Well, it was -2, but remember you changed the sign for the B. C is always the same, but remember when you take a number away from an x or put a number with an x, it always changes its sign. Okay? Now, 3. Test for your p-value. All right? I did end up rewriting their notes. First, okay, try p equals 2. Always try p equals 2. It's 99% of the time it's going to be 2. Occasionally they may slip in a 3 on you, but very rare. Because what happens when you take 4 to the third power? 4 to the third power is 64. Can you graph 64 on there easily? Just see what happens. That's why they keep it as 2s and 3s. Okay? All right, so we're going to test to see if 2 is our base, our p. So let's choose a test point. I need an x and a y value that's easy to read and easy to use. Where do I always try first? Y-intercept, which is right there. Can I read that point easily? Yes, they're pretty good about doing that. Okay? That's the point 0, comma what? 3. Okay? So, find a test point, and we like to use the y-intercept if possible. But it's not always possible. Yeah? Okay? C. Substitute to test. And remember, substitute just means plug in the x value and the y value, and then do the math. So, in place of y, I'm going to put what number? 3 from my point, right? Equals 2 to the x. I'm sorry, I've got an x value. What is my x value? 0 plus 2 minus 1. You see, all I did was take the x and the y from my point and plug them into the x and y in my equation, in my general form. Yes?
I'm confused
determine whether the P was 2 or not?
Just always try to. It almost always is. 99% of the time it's going to be 2.
I mean, what did you do after you put it into the equation?
Well, then I get a test equation. I think that's the right equation, right? Okay? So but I need to test it to see. And so what I did then was choose some other point on the line so to give me values to test. And here, it's pretty easy to read the Y-intercept. We always like to use it if possible because that always makes x equal 0. And so here it was easy to use, so that's what I did. So the Y-intercept is at 0, 3. So everywhere there was an x, I plugged in 0. Everywhere there was a y, I plugged in 3. Okay? Remember basic graphing. So that gives us 3 equals, well, 0 plus 2 is 2, right? And what is 2 to the second power? 4 minus your 1 gives us 3 equals what? Does it test? Yes. Therefore, that is my equation. And it usually is. Again, 99% of the time, P is going to be 2. But it could, in rare instances, be 3. So you need to be prepared to test these. If you don't test it, you're not going to know. Okay? All right. Let's look at another one. Give it a shot. This is not hard. It's just, first day back. Been a while. Got some stuff in there from the time 3 weeks ago when you had lives. Get over that. You don't have a life anymore. Remember, you're back to school. Okay. Let's look at another one. That one okay. What do you want to look at? You do this one? Let's use number 4.
What about 6 with the Y-intercept?
Oh, you can't read it? Oh, where it's 0, 0? Oh, 6. I love 6. 6 is easy. Super easy. Watch what happens. When you're testing it, it's super easy. Okay? We'll do 6. All right. First of all, right? Write down that general form. You've got to memorize it. Y equals what? P to the x plus or minus b plus or minus c. It's the same as a parabola and all the other things except your x is now up in an exponent instead of down in the bottom. Right? And you got a p. Okay, here we go. First thing I need to do is find the asymptote. What do you think the asymptote is here? Negative 1. Which automatically makes which thing negative 1? Your C. Right? The whole thing. The whole thing is negative 1. There you go. We're done. Moving on. No. C. Right? Because that's your downward shift. Okay? Now, where on this one is the graph 1 unit above the asymptote?
0, 0.
0, 0. Right there. Okay? Which tells us that we're not going to get from our point. We're not going right or left any, are we? No. So there's no shift right or left, isn't there? So that means that it's y equals, yes. That means not p is 0, but y equals p to the x plus 0. In other words, just plain old what? X. That's why I like this one. It's easy. Okay? All we have is a downward shift, and that's it. There's no left or right. Okay? Now, we're going to try it where p is 2 and see if that works. So I need a test point. Give me a point that's easy to read. What do you think? There you go. Doesn't matter. It can be any point on the line. It's not like other things where if you use one point, you can't use the same. If it's for one thing, you can't use it again. So we'll use 0, 0 as our test point. Right? So 0 equals 2 to the 0 minus 1. Which gives us 0 equals, what's 2 to the 0? 1. Sorry. Remember, anything to the 0 power is always 1. That's really important here for please. Anything to the 0, I'll show you in a minute. Hold on. Which gives us 0 equals 0. Okay? It's anything to the 0 power equals 1 is that rule. We've learned it before. If you have something divided by itself, if you use the algorithm for working with exponents, what is the algorithm for when you're dividing here? When you divide exponents, what do you do to them? Subtract them. So that's x to the 2 minus 2, which is x to the 0, which means that you were dividing something by itself, and anything divided by itself must be what?
1.
So therefore, anything to the 0 power must also equal 1. Because you get that 0 power by dividing something by itself. Okay? That's the proof. But close enough anyway. It's not a giant proof, but it'll work. Okay? So did it check?
Yeah.
Yep. So there is our equation. Okay? It's really not as bad as it looks. But again, you just have to start doing it. Okay? Yeah. You just have to remember, and we'll talk about it. But you just have to remember that with exponentials, the important part is the asymptote and one step above the asymptote. 1 unit above. If you remember those two things, then you can remember these. All right. So let's do a couple. They've only some, and we've done 2 of them already. So let's do the rest. So what is that? Page 73? Do 1 through 6. Now 1 and 2 are really scaffolded for you. And then the others, we've done 2 of the others. So you should be pretty good on this. All right. There you go.